So I'm going to do problem number 7, which is y double prime plus y prime minus 2y equals 0. And then we have y of 0 equals 1, y prime equals 1 as well. So the easiest way to solve this is to kind of set this up in r squared. So we have r squared, or we have r set up to r equals y. So this is going to be r squared, since it has double prime, plus r, or just r, minus 2 equals 0. And so we want to find out what adds to 1, but what multiplies to negative 2. It's pretty easy. Just do in your head. That's 2 and negative 1. Which means r equals negative 2 and 1. And we could just plug this into our general equation we have, which is y of t equals c1 ERT plus c2 ERT. So we can just plug r in, plug in for any, the first or second, doesn't really matter. c1 e to the negative 2 RT, or sorry, negative 2t, plus c2 e to the t. And we also want y double, or y prime. So we just derive it. Negative 2 comes down, that's negative 2 c1 e to the negative 2 2t plus c2 e to the t. And that is y and y prime. And since y of 0 and y prime of 0 both equal 1, it's pretty easy. So that means c1 plus c2 equals 1 for both. So we just set it up as c1 plus c2 equals 1, negative 2c1 plus... We can just use the constants, get rid of the e for now. And we would just want to solve for c1 and c2 when they're equal to each other. So we'll set this top one to negative. So that's negative 3c1 equals this negative 1 equals plus 1, 0. So c1 equals 0. And just plug that in here. 2c1 plus c2 equals 1. Alright, and then we can plug this in back to our equation up here. And then so we plug in c1 equals 0, so it's going to be 0 times anything plus 0. C2 is 1 e to the 2. Or sorry, e to the t. And then we know e to the t is this pretty easy graph. E to the t is always going to be going up. So the problem says as t increases, we can see that x, we can just describe it as e to the x. So as t increases, it grows exponentially. And that is the solution for problem number 7.